Hello everyone, welcome back to the next review of the Raku solutions of the weekly challenge, and today we're looking at the solutions to task number 1, GCD sum of week 89, and here's the task. So the task is you've got the number and write a script to add up GCDs of all possible unique pairs between 1 and n, probably including n, because here's an example, and in this example we see that like n is 3 and the pairs are 1 2 1 3 and 2 3, so 3 is included. Yeah, so and basically the sum of those results of those function calls is this. Yeah, of course, definitely it depends if you create a function yourself or if you're using a library function, but yeah, the result should be the same. Yeah, so simple. So we can go straight to the solution, so recap. But before I will go there, and it's really nice that there are new names, at least for the few past weeks. Please don't use old extensions like P6 or PL6 or PM6 or whatever. Start use .raku test Raku mod and Raku doc. Yeah, maybe these tests and docs and maybe even mod are not that required in the weekly challenges, but nevertheless, the thing is that GitHub really wants to see as many Raku files as possible to activate the type recognition by file extension. So currently it's only possible to syntax highlight files with .p6, yeah, or PL6, but not Raku. But okay, nevertheless, so the first solution here is IronSmith Raku number 1. So here's the solution. Yeah, actually, yeah, so I hope we will be quick this time today. So there's the sub function main. Basically, yeah, there's the only subroutine here in this file. Yeah, again, so we see, so PL6, and here is Raku. Yeah, so we take n, which is an integer, and it should be positive. Then we create these pairs. There's a really nice addition to Raku. I don't know who proposed that and when, but nevertheless it's there, so we can just use this combinations method to generate combinations of two numbers from this range. Very, very handy. And after that, what we do, we map all those pairs into basically their GCD. Notice that GCD is a built-in function in Raku, but it's not a regular function, it's just the infix. So you cannot call it like GCD parentheses and a couple of things. You have to do it like this, so you have to put it in between the two operands. Yeah, and after that you add up everything that you mapped and print it. So yeah, we can run this. So it's Raku Raku. Oh yeah, run this one, right? Raku ch1, no ch1, and I will try to test all the solutions if that's possible on this number. So this is the result, 13,015 for the input number 100. Oh, okay, so it works and works properly, and the solution is quite compact, and we can go next. And next is Clifton Woodrock number 1. So here's the solution again. So, but this time we're using the function prompt to ask the user to enter something. This something is number. Definitely this number, this $n will get the string, so we can, it's actually a string, but if we use it here in the sequence, so definitely it will be converted to number. We don't have to worry about that. Then we've got all those combinations, and there's another map similar to the previous solution. And yeah, and here that's the nice case when you have to start, or you can start. You can put dot before square brackets just to call this method for subscripting on the $_, and after that you add everything up. So instead of reduction operator in front, you can use .sum in the end, and then output. Good. So Raku xlif Raku ch1 100. Oh no, yeah, 100 result is correct. Good. Function Raku number 1. Right, so there's the challenge. Yeah, the program is really big, but it's actually really small, right? So main, we've got this unsigned integer defined n in the input, but this time it's a bit different. So yeah, there's no combinations. I mean, there's no call of method combinations, but there's this kind of multiplication table. Yeah, the Cartesian product of two ranges from 1 to n. Probably we can use hat before n, and we don't need -1 then. And the second thing is just 2 from 2. Basically, the left edge of the second range is bigger than the left edge just by 1 of the first range, and we end until the end, right? But because we need only unique things like 1, 2, 1, 3, but not 2, 1, then we want to have this grep again. You see, so dot then square brackets to subscript the $_ thing, and we only select things where the second argument is bigger than the first one, right? After that, we map that again with a similar construction and add everything up and print it. Right, so let's run this Raku feng chunk Raku ch1 ch1 Raku 100. Right, the result is really good. Okay, Jan Krnavik, Raku number 1. So we've got a couple of main functions, multi-sub. You see, so multi or multi-sub, both are possible. You don't have to explicitly type sub here in this case. I would type it, I prefer, but yeah, definitely it's your choice. And so this function is for tests if you have --test in the command line. Otherwise, it will use the number from command line, and then we call this function GCD sum. Actually, we have well, two nested function calls, right? So we don't have any parentheses, but nevertheless, so first you call this GCD-sum, and after that, the result will be passed to say. So GCD sum, that number, so we've got this range, so we created this range, and then we apply something to that range. So in this case, we apply combinations. You see, again, so instead of parentheses, you can use a colon, which makes it a bit less noisy, right? You don't have many characters. And after that, you apply to the result of the previous operation to basically two combinations another method map, and you GCD this, and you see, so unlike previous solutions, here we have a reduction operator with the GCD function inside it. So basically it will enroll those things in $_, but this is an array, right? So well, a sequence, there are two elements there, so it will be like $_ square brackets 0 GCD $_ square brackets 1. So, right, and after that we apply sum. I don't quite understand why we need this on-space thing here. I think it should work without that, but nevertheless, so yeah, here's the thing. Actually, maybe we can even maybe I can, because I really don't understand why we need this. So let's run this thing, Raku t.Raku 100, right? So this is the result, and what if I will remove this character? Sorry, wow, undeclared routine, really? Ah, yeah, probably this happens because this, yeah, so Raku cannot understand where this arguments of this map ends, right? So yeah, we need either to have these parentheses or, oh, really? So basically this unspace actually helps. Okay, interesting, I didn't know about this feature. But yeah, nevertheless, so this is what we have here. So the solution is a working solution, and we can go next. Next is Kangmin Leo, Raku number 1. So here's the solution. Yeah, again, so yeah, I see, so there's .raku, and there's no shebang here, and GitHub refuses to colorize this text, which is not good. But yeah, the solution is still good. So we've actually, yeah, so this this solution will print the result for all the numbers in the command line. Yeah, okay, so it would take n and we convert it to integer. Probably don't even need to do that, but yeah, this function requires an int, and then we make the combinations from this range and map those to, yeah, so it's here we have a pointing block with an explicit pair of parameters a and b. Yeah, some, that's it. So yeah, right, so let's run this Raku Raku ch1 100, right, the correct result was printed. Mark Anderson, Raku number 1. Okay, so here we have a couple of tests. So we cannot enter the, oh no, we can. So we can, because there's another multi-function, and we demand here that the input number is integer, unsigned, and bigger than 0. Well, wait, unsigned and bigger than 0 is kind of, yeah, repeating the same, right? Oh wait, let's just run this function. So okay, so first let's run this Raku. Okay, so Raku T. So it prints the correct result. How do we achieve this result? So again, so yeah, we just make combinations and map those to these. But I wonder what happens if you will pass this. No, first of all, we will try to do it like this, usage, right? And let me just remove this function. Okay, greater than 0. So this, by the way, you see, so this is how you can add, yeah, this is where we have it, right? So yeah, you can add this nice addition, some explanation about the values of the arguments you expect, but I wanted to just remove this one because yeah, so it's the same, right? Because, and if I will do it like this, then it accepts, yeah, of course the program breaks, but it's not important. But the thing is that you already made this restriction by just specifying the type. Yeah, and then the program was broken on the call to GCD-sum because it also expects this unsigned integer. Okay, nice and good thing. Right, okay, so let's go next. Philip Hood, Raku number 1. So we've got the function with some positive n, and by the way, okay, so yeah, unsigned in the previous solution, actually it's unsigned, but we can call it with 0, right? So 0 will pass this. Okay, yeah, probably then yeah, we need this. Okay, right. So back to this solution by Philip Hood, right? So I've got this V, probably it's, I would say it's result, but it's not a result, it's some accumulator. Okay, yeah, that's the result, right? What's this through then? So yeah, probably this program prints some steps. Okay, yeah, it indeed. So we take the range, we make combinations, then we map these. So we add the thing to the result, the GCD thing, and we also, okay, I would say I like it, but yeah, it's kind of 2 actions in 1 block. But the last action, the last computed value is actually the return value of this whole block, which is a string with interpolated input numbers, A and B's and A and B, and after that we just join it, all those substrings like this. We join that with plus and print in the output right here. Okay, yeah, well, actually, yeah, probably if I was doing that, if I were doing that, then I would probably have another, just this str, I would just assign it like str plus equals, well, what is it, tilde equals this, right? Yeah, maybe, yeah, join str. Okay, yeah, it's a difficult question how to gain a few characters, but nevertheless, okay, so we understand the solution. So let's run it. P K M, right, Raku 100. Ooh, yeah. Ooh, where's the beginning? The beginning is somewhere there, and the result is correct. Yeah. So, and here we see the the way to compute this. But nevertheless, you see how it works, right? Good. Going next. Simon Proctor, Raku number 1. Let's look at the solution. So we've got this main function with here we just accept the unsigned integer. And yeah, so this just add up everything which was obtained from the range, then by combinations of 2 elements, and those were mapped to get the GCD of those 2 numbers in this combination. Right, so yeah, I assume we just can get the correct result. Simon Proctor, Raku 100. Yeah, good. Still a little. rock number 1. Yeah, P6. So yeah, see, so but the thing is that you see, so with P6, GitHub does highlight this file. but so yeah, just really let's use .raku. It will eventually make GitHub to yeah to think that this is a good extension .raku. Okay, nevertheless, so what we have here, so we have here the direct argument, the first argument from command line converted to integer and used in this range. So yeah, no separate variables, combinations to map, yeah, and we map those to the GCD, and then we add this up. Actually, yeah, probably we can even attach .sum here in the end instead of calling this as a function. Raku Stuart Little, Raku ch1, Raku 100. Yes, good. Okay, now it's my solution. Yeah, I believe you will recognize the solution. Oh my god, no, it's, what's that? Okay, so it's Perl, right? So because, yeah, I will probably have a separate video because I solved this task in 22 programming languages, and yeah, so in the 2 of them are Perl and Raku, and in Raku, yeah, definitely I'm taking the arguments. I have some default value, and after that, so I take the combinations, I map those. You see, so again, so I use I don't quite actually like it because I'm using the colon syntax to pass the argument to this map function method, but I still have to use $_ and parentheses. So I would say I would love to have star here, but it doesn't work. Yeah, maybe you can explain me why. Yeah, so let's run it. Raku ash Raku ch1.raku 100. Yeah, and by the way, so you see, so there's Raku, but there's some syntax highlighting. This is because I have this shebang with some Raku. I'm not sure that I have to have it as a separate word, or will it work like USR being Raku? You can try. Yeah, but that's the current trick to allow syntax to activate syntax highlighting for your file on GitHub. Right, going next, IronSmith, rock number 1. Ooh, right, so it's much bigger than all the rest because probably, yeah, I see, so there's no yeah, let's see, no, actually, yeah, GCD, but GCD is not a built-in function for some reason. I don't know why. Maybe it's explained in the blog. I didn't read it yet, but okay, so let's see. So there's a subset of integers, of positive, basically integers, and we demand it as the command line argument. Then we take the range, combinations, map. Okay, so we see, so this is the combination which is called method operator. So there's a function, but you can call it as a method on basically on this $_ right in this case, and you add it up. And okay, so here we have the GCD function implemented manually, and we take some numbers. Well, in our case, it always will be 2 numbers, I assume. Yeah, I mean, if there are no other calls. But first we have some, we determine some common divisors, you see, so there's the set operation, and for the intersection, right? And after that, so we take the keys, basically sort them, and the GCD is the biggest because it's the greatest, right? So if you sort it, the last one is the 1. So this is how you take the last one in Raku. You can also use .tail method, right? And you return this. And divisors, so number, not self, not 1. Right, so what do you want? Not 1, so yeah, there are some flags. Candidate, and you push this candidate if number is divisible by this candidate, right? Okay, push not self. Okay, so you don't want to push the, I don't quite understand how it works, but obviously it works. I don't quite understand why we need a separate implementation in Raku, because we have already this GCD function, right? So it's called GCD. It's not a function, it's a binary infix operator. Raku IronSmith Raku ch1 Raku. Oops, and the result isn't correct. Wow, I don't believe that. 3, 4 is the same. Why is it different for 100? I don't know. So yeah, we can, well, yeah, I cannot understand it from just looking. Definitely we can debug it. Maybe we can do it like this, right? All your good luck. Yeah. Okay. So yeah, there's something there. Okay. Athanasius, track number 1. Poll weekly challenge 89, and here's the function. Right. So we've got So here is the way to get the combinations, the unique combinations of those two numbers, and it's just you can organize a couple of loops, nested loops, and yeah. So first you scan it up to the previous to the end, and after that you start the second loop just starting from the current value on the outer loop, right? And just for some for making the code better, there's a subset of positive integers, right? So, and all those definitely are positive, right? Because these are always bigger than 1, and they're integers. And yeah, so after that you've got the unique combinations in which I is always less than j. By the way, that can be important if you implement GCD yourself. And yeah, just add those things up and print it. Very simple. So Raku Athanasius Raku Ch1 100, not 100. Right, the result is very, very correct. Good. Colin Crane, Raku number 1. Raku number 1. So we've got the thing with unit submain. So basically this is the body of the main function, so the whole file is the body of the main function. It takes the input number, which is an integer, and it should be a positive integer, and the default value is 100. And after that, so we take those combinations of this range, we map these. Okay, so we saw all the elements of this program. Then we just can run it. Raku, you see, so yeah, Raku really gives us oh no, 100 is better than 1000, probably it's a bit faster. Right, the result is correct. So Raku gives us two great things: the combinations method and the GCD operator. I don't understand why the GCD is an operator, not just a function in Raku, but nevertheless, so we can use it. Raku. Okay, so Jaldar Vyas, Raku number 1. It's a command line thing, and probably, yeah, but we see all the elements. So we take the first argument, combinations, and map those. Probably I even don't have to run it, but I will. Raku. Jaldar. Raku. Ch1.sh. But it's not Raku then, right? It's bash or zsh, okay, bash. And 100. Right. Good. Julio de Castro, Raku number 1. So we've got the, where do we start? So see, so arguments, if there's one argument, then we do something with this function, otherwise we exit, and otherwise we just use test, and we make some tests. Right, so okay, GCD sum of the, see, so this is how you can take the first element, just use the head method, you convert it to integer after that. Again, you don't have to really do it here, Raku will do it for you, but nevertheless. So take the range, you see, so yeah, that's also the thing you have to decide of yourself, whether you put spaces around this operator or not. I usually prefer not to put spaces in this case, but as soon, for example, I have like n+1 here, I will put space both here and here. Right, combinations, and then you map those. You see, so here, that's an interesting thing. So that's the placeholder operator, but it's not just the dollar, the scalar, it's an array placeholder. So you can call it whatever you want, A, B, C, you can call it it, and it will be passed to this reduction operator with the GCD in its heart. So basically it will insert the GCD thing, the binary GCD call operator between all those elements in this array. And after that you add those things up. Right, so Raku, Julio de Castro, Raku Ch1 100. Right, that's correct. Lauren Rosenfeld, Raku number 1. Okay, so yeah, see, so again, Raku, there's no shebang here and no syntax highlighting, unfortunately, but nevertheless, so see, ooh, wow, what's that? What's that? Let's run this program first. I don't understand how it works. Allow run Rosenfeld Raku Ch1 and 100, right? Is the input, right? So yeah, I believe this is some typo, right? Because it's not what I expect here. So I believe let's just remove these things, right? And Raku, no, it's minus. Ooh, yeah, but the result is correct. But how do we achieve this result? So we take the thing from I believe it's not quite what was intended here, but nevertheless, so we take the combinations and then we map those to get this GCD thingy, then we add those up, but we do, okay, so yeah, but actually, yeah, you don't have to do it like this, right? Okay, so probably just, I don't know what Lauren wanted to do here, but nevertheless, so to get one last thing, we can do it like this. Okay, good. Yeah, probably you have to go to his blog to see the explanation. Yeah, I see. So he really wants to print everything. Okay, right. Yeah, and actually, see. So we see this here. I don't understand why we still see it there. Rack has a infix GCD operator which computes the GCD for us, thus changing the combinations GCD map and some built-in routines yields a solution fitting in just one line. That's right. We could, but nothing about this. I believe it's just a typo which was not noticed. But okay, the solution gives the correct result, which is good. Okay, Roger Bell West, Raku 1. Right, so here we have another program where the GCD is implemented manually, but the main function is GS and tot, it's Dutch tot, n -1. So we scan those things. Okay, yeah, I see. So you see, so there's the way to organize those two nested loops. The first loop is explicit, but the second loop is actually here. So we map this this as a function. We map this range to the sequence of GCDs, right? But then we apply this. We do this inside the out loop, right? And after this, the total result. I will not dig into the implementation of this function because it's, well, there are different approaches and this approach seems to be quite efficient, but nevertheless, let's just run it. Raku Roger Bell West Raku 100. Yeah, so 100 is ignored because there are a couple of test cases and we don't know if it will work for all the things, but I can just copy these because there was a solution that didn't work, like the test cases worked, and when we don't have any tests, but we just GS of 100, right? And we can print it. Okay, Raku T, right, this is the correct result. Okay, and the final code in this list, Raku solution by Ulrich Rieke, Raku number 1. Right, the file extension is good, but GitHub is not. So main integer n, we collect some GCDs. After that, we just add those up and print. But how do we collect? So we organize the loop, and we loop all of. Okay, so yeah, instead of map, you can use definitely a loop. And so this combi contains a couple of elements, zeros in first. You GCD them and you push it to the array, after which you use this array and add the elements of the array together. Okay, Raku Ulrich Raku Ch1 100. Voila. Right, so it works. So all the solutions are there. So yeah, it was quite quick because the task was actually pretty much easy. Right. Okay, so yeah, thanks for watching, and yeah, there will be more very soon.